Assalamualaikum warahmatullahi wabarakatuh. My name is Aira Shiga binti Musa, and I'm from Faculty of Computer and Electric and Electronic from University Tun Hussein, Malaysia. And my supervisor name is the Esplanade Fatih bin Muhammad Noor. So the title of my project is an iterative web application for GCPV system sizing. So the first one is about the introduction. So growing demand for clean energy makes solar PV to the future. And then one of the problem is the manual PV sizing is very complex and often become oversized or undersized. So we come up with the ideal web-based application that make PV system design simple, smart, and cost-savvy. So the next one is the three main problem statement, which is it's very common. The first one is spatial shading issue, and then the costing is very high. And one of the things that come out is the complex method of sizing GCPV system. So we come up with this idea. So the objective of this project is to perform and sizing GCPV system for residential area, and then to integrate the size of DC optimizer in GCPV system. And the last one is to analyze the performance between the when we use and without use this optimizer. One of the value of this project is we add a DC optimizer in each of PV panel. So the location, from the methodology, the location is a single story houses from Taman University, Karachi, Johor, and then we use the annual TNB electricity for 1 year of the real household energy data. So here is the location and the bills. So the result and discussion the result is generate a graph so we can easily see. The gray one is without the DC optimizer, and the green one is with DC optimizer, which is we can see it's increasing after using the DC optimizer. So here is where we put the DC optimizer, which is in each PV panel. So I'm going to demo a little bit about the application. So we press start. So after we press that, you can see it's just simple. We need to add all the parameter, panel length, panel width, rated power, all this parameter, and then it come out with 7 module. The result is 7 module. So the next part is about the inverter. Inverter also we put parameter from the data sheet, and then we get a MPPT, how MPPT and how module inverter. And the part C, it's the DC optimizer. Same goes to previous one. We get how DC optimizer. And then the last one is part D where it generates the graph. Okay, the performance of using DC optimizer. So I'm going to continue with my slide. So the benefit is to provide accurate and optimize the PV system sizing. To preventing the oversizing and undersizing, we need to put the range, and then we use the real house energy data. So to ensure the practicability of real world relevance, and then as a student who take PV, so we want to promote the solar energy adoption by making the PV sizing become more easier for the student, homeowner, and industry user. So the target is homeowner and then the student who learning solar energy to become to make them save the time. So we can use at the educational and practical PIP sensing tools. And then the publication, the title of the paper is optimal sizing of GCPV system with DC optimizer for residential application in Taman University Batu Pahat, Johor. So this innovation has been successfully presented at the international conference on September this year. So here is the paper. And then I'm already win 3 award, gold, silver, and bronze medal at the competition. And then the copyright registration process for this innovation is currently being planned. And then the grant is Tier 1 Research Grant QX78. And then the conclusion is we want to achieve all the objective, which is the first one is the interactive web-based to successfully size the PV system accurate for residential need. And then it simplify design the process, turning the complex manual calculation into an easy user-friendly experience. And then by preventing the over and undersizing tools and ensure optimize the system design and reliable performance after using the DC optimizer. So I think that's all from me. So thank you.